Okay, now I'm gonna try to solve the second part of this circuit here. For t larger than 0, what happens is this switch opens, and this u of t turns 1, so now this power supply is in the circuit. But this part here is out of the circuit. And the way to draw at t larger than 0, because I want to know the derivatives, is that I leave the capacitor and the inductor in the circuit. So here's how the circuit looks. So now instead of u of t, I am actually writing the 2 milliamps. This is what it means to leave the u of t out of the circuit. This is IL. So now I have a circuit that is almost series, right? So now I can do a source transformation here and actually have this all in series. And I'm going to already add the 2.5 to a 3 kilo ohm resistor. And I'm going to use here a voltage supply. And this will be 5 volts, and this will be 3 kilo ohms. And now I want this VC and this IL. Actually, I have the current there. Now I'm going to do KVL on that single loop here that I have. And I'm going to use this IL direction. So this is the IL through the kilo ohm, through the 3 kilo ohms. So I'm going to use this voltage drop this way. Same thing here with the IL. So I'm going to start here, VC plus 5 minus the voltage on the 3 kilo ohms minus the voltage across the inductor equals 0. So hopefully everybody remembers how to do KVL. The sum around the whole loop of the voltage drops equals 0. So now I have VC. So what happens is I have these two values from before 0 that I can transfer, but I only have the VC and the IL. So VC, I know is minus 0.5 plus 5 minus the voltage across the 3 kilo ohm is 3K times IL minus L di dt equals 0. So now 4.5 minus 3K times minus 1 milli minus 0.5 di dt equals 0. So now this here is 3 volts. So now this is 7.5. And so I have finally 7.5 is 0.5 di dt, and this is only valued, you know, it's only at 0 plus. So finally I may need to use dIL dt at 0 plus is 15 amps per second. So now I have this, and I still need VC V0, dVC dt at 0, and that for a series circuit is the easiest part. Let me change colors. So oh my gosh, that's not a good color, is it? That current, this current through the circuit is C dV dt. Actually, the current through the capacitor is this way, IC. But now IC is minus IL, so I need to write here 1 milliamp, because IO is -1, equals dV dt at 0 plus. And that means dVc dt at 0 plus is 100 volts per second. So all series circuits that have a capacitor in series with an inductor, you get the current from the inductor at 0, which is 1 milli, or the inverse of it depending on the passive convention. And you divide by the capacitor value, and that gives you dVc dt at 0. So in the next video, we'll do final values.